Let's continue analyzing graphs of polynomial functions. So let's take a look at even versus odd functions. Now, up to this point, we've been talking about even and odd degree, but now we're going to talk about whether they're even and or odd functions, okay, or neither. So a function f is an even function when you plug in negative x into the function and it's still f of x, or no changes for all x in its domain. The graph of an even function is symmetric about the y-axis. Okay? So a function f is an odd function when f of negative x equals negative f of x for all x in its domain. The graph of an odd function is symmetric about the origin. So we'll see some examples of those graphs. One way to recognize a graph that is symmetric about the origin is that it looks the same after a 180-degree rotation about the origin. Okay, so that's just a little hint they put in the book. Now let's take a look at an even function. What does that look like? An even function, well, we know even, if we have this graph here, okay, if we plugged in, let's see, if we plugged in an x, we would have this y. If we plugged in a negative x, we would still have a positive y. So for an even function, if xy is on the graph, then negative xy is also on the graph. Okay, and notice that it's symmetric about the y-axis. If I put a mirror on that y-axis, it would be the exact same on the other side. Let's take a look at an odd function. An odd function. So it could be something like this. So for an odd function, let's see, if we plug in xy, positive x, positive y, then if we plugged in a negative x, we would get a negative y. So for an odd function, if xy is on the graph, then negative x, negative y is also on the graph. Okay, and it's symmetric about the origin. Sorry, I should do that a little better on there. If we rotated that 180 degrees, it would still be the same picture. So let's try, we just want to identify even and odd functions, determine whether each function is even, odd, or neither. So what we're going to do to test that out is just plug in a negative x. So f of negative x. So negative x raised to the cube minus 7 to the negative x. This raised to the cube, we know that will end up being a negative x cubed, and then negative 7 and negative x, that would be a positive 7x. So f of negative x, that does equal negative f of x. So that's true because the signs change, right? This is positive, this is negative. So it changed to now this is negative and this is positive, right? They're all opposite signs. So therefore, this first example is odd. Let's try the next example. We plug in g of negative x raised to the 4th power plus negative x squared minus 1. So we would get positive x to the 4th, a positive x squared, and then a negative 1 here. So when we plugged in a negative x, what resulted was a positive g of x, right? It's the same exact signs as before. Positive, positive, negative, positive, positive, negative, okay? So if you plug in a negative x and you get the same exact function back, right? No changes in sign at all, then this is an even function. Versus the other example where we plugged it in and all the signs change. Let's take a look at this third example. Let's plug in a negative x to the cube plus 2. So this changes to a negative x cubed and then a positive 2. Now, h of negative x. Does that equal the same exact function, h of x in the beginning? No, because this is positive, positive, right? This is not positive, positive. Does h of negative x equal negative h of x in this case? So did all the signs change? No, again, because originally it was positive, positive. If it was true, then it should be negative, negative, which it is not. So if you get neither one, then that means, therefore, this is neither even or odd. Okay, neither even or odd. Try these three, pause it, and then I'll give you this one. If you tried it out, this should be even. Try it out the next one, this would be neither. And the last example would be